Okay. Hello, everyone. GM, how y'all doing? We're closing up third week of Block Magic. Wow, 3 weeks. Time flies by, really. I hope everyone is having fun, that you are building scribble projects. We're so excited to see what you come up with. And today we have the pleasure to be here with Ahmed from Scroll. And we're going to, not we, he, will talk to you about how to get started with DK on Scroll. And with that, Ahmed, I'll pass it over to you.
Thank you, Sophia. Yeah, we're happy to be here. And yeah, thanks for having us. And yeah, this is going to be an introduction to creating CK apps, apps with privacy enabled. If you are a Solidity developer, if you already know how to code smart contracts, if you already know how to do front-end interface for your smart contracts, you are already more than half there. So we're going to learn that next step that you need to know to create privacy applications in Scroll or any EVM chain. So yeah, my name is Ahmed. I am developer at Scroll. So I do a video and article content for Web3 developers, mainly in Spanish, but also in English. And yeah, today we're going to take a look at how to do exactly this. So imagine that you can make functions in your Solidity contracts that have parameters, and those parameters are private. So for example, if you have a transfer function that you're able to send some coins to another address, but without revealing which address is that. And this is obviously not possible on the EVM chain. Everything is public. So yeah, that's what we're going to learn how to do today. How to pass private parameters to your function. Also, if you have any questions, drop them in the chat. We will be. I try to answer them the best as I can. There are no too basic questions, and also there are no too advanced questions. If I'm not able to answer, I can ask internally in the Scroll team for a better answer. So yeah, this is what we're going to learn how to do. Of course, it's not that straightforward because Ethereum don't allow this by default. So we are going to learn how to do circuits because we need circuits to be able to do this. So what we're going to cover today, so we're going to learn what are circuits and how they can enable private parameters to your functions. And we're going to do a live demo. And then we're going to open the scope. We're going to zoom out and repeat. And we're going to do two demos. One demo is going to be the hello world, very simple to get you started, so you have a better idea on how everything works behind the scenes. And then we're going to do a more advanced demo uh, where you can learn about the general architecture of a CK dApp for like a production um, production ready environment, what you need to learn. And at the end, we're going to discuss a bit about the current state of CK, what are the challenges right now that you may face as a developer. Also, I'm going to give my opinion, my take about where this is moving forward. Okay, so let's get started with what is a circuit. And this is all this presentation is going to be intended for developers. And right now, you know that zero knowledge is a very new technology, and it's being created or it's being like pioneered by a lot of math researchers. So right now, the documentation that's out there mostly is intended for math people, but we're going to focus this for developers. So for all the mathematicians there, excuse me if I um, say something like incorrectly, but yeah, just trying to focus on developers. And yeah, basically, so you feel familiarized with circuits and know what to expect from this. Okay, so if you here in the left, you can see what is a typical function, and us developer, we are used to this. We have some input and some output. For example, x and y is your input, then you go to a function and you make a process, and you have an output, in this case seed. So x and y is your input, your function is a process, and seed is your output. So this is how everything usually works in no matter the field you work on. If it's web 2, web 3, whatever, it's usually this way. But with circuits, it's a little bit different. You have a lot of similarities, and you will see the syntax is very similar, but the idea is a bit different. So at the beginning, we have to get used to this different idea. So when you create a circuit for using CK, you have as a parameter, you have the input, the output as a parameter to the circuit. And it's no longer like you have the input output thing, but all your input or your output are your params to your circuit. And then the circuit is able to produce a proof that for X and Y input, you will have the seed output, and it will produce a proof. And then that proof can be sent to a smart contract. And after that, the whole development that you're used to is applies the same way. Now, different projects use this in a different way. So if you are a developer, you may want to create, for example, a privacy voting application, for example, and you can pass the as a private parameters, publics and parameter like as parameters, you can pass the vote and 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 the vote itself can be private, and those can be generated. You can generate a proof, so you can convince a smart contract that the vote was casted without revealing who was the voter. So you're able to do this, but on in this way you can create privacy apps. We're going to learn how to, yeah, we're going to in the demo we're going to be able to see yeah how to do this. But basically you can create DeFi applications, social applications, everything that can be privacy enabled. Video games, for example, too, are a very are a use case for zero knowledge. And but for example, Scroll itself, it uses this in a different way. Scroll uses not for privacy, but for scalability. So in Scroll, as a public parameter, you pass all the transactions that all the users did, and you generate a proof that all the transactions were executed correctly. And that proof gets sent to Ethereum mainnet for security and validation. So there are two types of application that you can do: scalability, like Scroll, or privacy, like games, voting, or DeFi. And in this case, we're just going to focus on privacy. So because you can build your privacy applications on top of Scroll, but Scroll, just as Ethereum, has not privacy-enabled features, but it's the ideal place to generate to create this privacy application, and we're going to talk about it in a moment. But yeah, just know that for deploying on Scroll, for releasing on Scroll, you don't need to know anything about zero knowledge. It's a common misconception, but no, it's you can deploy um, any type of application, NFTs, DeFi, whatever. You can do that on Scroll, but Scroll is a good place to create privacy-enabled applications, and we're going to see why. And okay, so the first steps with CK, what you need to know. So for creating a CK project, you will, the most basic three things that you will need is a circuit, a verifier contract, and solidity logic. So with the solidity logic, you may be familiarized, but we're going to see now what is a circuit and what is a verifier contract. And after that, you will be able to apply all your solidity knowledge just the same way as you have learned before. And we're going to do this. We're going to create a front end. We're going to create a this is like the basic way of creating a CK app. You will need a front end where you generate private inputs, and you will need a contract where you verify that your computation was correct, and then you can add whatever other logic that you want, being DeFi, voting games, whatever you want to build on top of that. So these are the two things that we're going to learn. So now I'm going to share with you this gist, so you can feel free to scan this QR, and this will take you to let me check if it's correct. Yes. This will take you to a gist. If you want to follow along with me, we're going to create the hello world of creating a circuit. So I'm going to explain step by step everything you need to get started with building your privacy-enabled application. In this case, we're going to use Aztec Noir, but you can also use Circom, Socrates, even Halo 2. But yeah, there are different circuit language, circuit tools that will help you building privacy applications. But for now, we're going to see Aztec for your Hello World application. So now I'm going to stop sharing, and I'm going to share my whole screen. I'll ask Sophia to help me put in the full. Thank you. Here you go. So this is the gist that I shared with you guys. So first, you can install on your operating system, or either Linux or Mac. You can install Aztec Noir. Just paste all these contracts. It shouldn't take too long to install. And then we're going to create the circuit. So, okay, let's do that. So I'm going to just create all of this, and also going to create a new project and also build it, like compiling it, and also do this check. We're going to see now what was this all about. Okay, so how does a circuit looks like? So this is how a circuit looks like. And you may feel like it's very similar to a programming language, and yeah, that's the case. For example, Noir, it's heavily inspired in Rust. So yeah, and actually this is just a test. This is the actual circuit. So what is the circuit about? So the circuit is received as parameter two fields or two variables, X and Y. And this can be like inputs from the user. And then the circuit asserts or checks that X and Y are different. So this is a circuit that where a user inputs two numbers, and the circuit check that the numbers are different. So you will only be able to generate a proof of correct computation only if the two numbers are different. But there is one important thing here. The most important thing here is this word pub. Pub is for public. So in Noir, all the parameters are private by default. And if you put the pub word, it's going to make it public. So what does it mean? So it means that X is going to be private and Y is going to be public. So for example, if you are making a voting application. You can make your vote, like if you voted for or against or abstain, if you're making that vote, that output can be public, but the voter itself can be private. For example, if you're making a DeFi application, you can make the receiver private, but the amount sent public. So it depends on the application that you want to build, but you can play around as a developer and create different types of applications. And yeah, this is pretty simple, as you can see. This is just to get started, just two numbers, one public, one private. But this is the foundation. This is what you need to understand before going to the next level. Okay, so let's try this out. Let's follow our gist. So the next step is just to input your params x and y. Remember, x is private and y is public. So that you can put whatever numbers you want as long as they're different. And this one is going to be private and this one is going to be public. So let's go here in the prover.toml file and yeah, just save this. So these are our inputs. And now we're going to generate a proof. And what is a proof? A proof is basically a super big number that proves that the computation was made. What is the computation? In this case, checking that the two numbers are different. So you can see the proof here. A new folder named proof was generated with a huge number. This is a super big number, and that was generated, and this is going to be sent to the smart contract. And the smart contract, just by watching this number, it will be able to check that you pass two numbers as a parameters, and you check that the two are different. So yeah, that's the magical part. So let's try this out. Let's see how it works. And remember that I know that this in the beginning can be very different and a bit hard to understand. But the more you learn more about it, it gets easier. So also, if you have any question, feel free to put it in the chat, because I know this is not something easy. At least for me, it wasn't easy to understand, like the first time that I was exposed to all of this. Okay, so now we're going to launch a smart contract. It's going to be the verifier smart contract, and I'm going to paste this code here. So this code was generated by this command, the nargo code gen verifier. So what it does is that it, as you can see, it generates a new Solidity file. I didn't write this. This is full of a lot of like seemingly random numbers, which are not random, of course, but basically this contract has one function in specific that it's the verify function. So the verify function receives two things as a parameters. One is the proof, and the second is the public inputs. So the proof is the proof that you computed something correctly, and the public inputs are an array with all the public inputs. Remember that x and y is private. X is private and y is public. So here we're going to receive as an array the y parameter. So yeah, this is and so that's the different thing. For example, if you are making, for example, a voting application, a private voting application, the vote itself is public. So you will receive it as a public input. And the voter is private. So you will receive the proof that you are a valid voter as the proof, but it won't be visible on Solidity. So that's why we call this off-chain computation. So CK is able to compute things off-chain. So by off-chain, we mean in the circuit, generate a proof of that computation, and then pass it to a smart contract to generate an on-chain and public computation. and verifiable computation. Because if we just make computation in our machine, it doesn't mean a lot, right? It's like going back to Web 2. But if we make a computation off-chain and then generate a proof, and then we're able to prove that the computation was correct, you can unlock a lot of new use cases. Okay, so let's try this out. So we're going to deploy this contract. So here I'm going to compile. Also, you will need to enable the optimizations to be able to compile this. This just because this verifier contract is too big. And now we're going to deploy it. I'm going to deploy it. I'm here on Scroll. And remember that I mentioned that Scroll is ideal for deploying privacy applications. And that's not because Scroll uses CK itself. It's not about. Actually, it's the opposite. So you can make what we're doing here. You can do this and on Ethereum mainnet. Also, you can make this in all the optimistic rollups and all the alternative layer ones. But because it uses some very specific precompiles, and it needs to be deployed only in chains that are like extremely similar to Ethereum. So Scroll, because it has prioritized the most important features, today is the only CK EVM that is able to deploy and use verifier contracts like the one that we just deployed here. So here right now I'm in Scroll. I was able to deploy this contract. Scroll is the only CK EVM where you can do this, because Scroll has prioritized the a lot of very important precompiles that are used to create this verifier contract. So yeah, Scroll, like this, I think we're very happy to be able to support all like Circum, Socrates, Noir. Yeah. So if you want to build a CK application and you want to benefit from lower gas fees and quick finality time that is offered by EVM, CK EVM chains, yeah, the best place is Scroll, because only here it's possible. Okay, so let's continue. Now we are going to deploy another contract, and I'm going to explain this in a moment. So this contract, I like to call him the custom logic contract. So what does it do? So it has a reference that you pass in the constructor. It has a reference to the verified contract, the contract that we just launched, and the contract that is able to verify the proofs. So it has a reference. So in the custom logic contract, you verify that the proof is correct by calling the other contract, doing contract interoperability. So it calls the other contract to check if the proof was correct, and if the proof was correct, you can do whatever other custom logic you want to add to your contract. So if you're doing a DeFi application, here is where you're going to do all the transactions. If you're doing a voting contract, this is where you're going to do all the voting. If you're doing a video game, so here's where you're going to handle all the logic from the video game, etc. So the custom logic contract usually has two parts. First is the verification, like the proof verification, and the second part is what I call custom logic. So you as a developer can use all the skills that you already have on Solidity to create a custom logic once you verify correctly the proof. So two new tools are: one, the proof that something was computed correctly, and two, the public input that you can use to create some extra logic. So in this case, we're going to do something very, very simple. Just count how many valid proofs were sent. You're just going to count one by one. Not very exciting, I know, but after this, we're going to be looking at a more complex example, and yeah, we're going to be doing a chat application with privacy features. Okay, so I'm going to compile this and I'm going to launch this. But to launch it, it will ask me for the verifier, the contract that we just launched. So I paste it here, and we should be good to go. And then when I send the proof here, now that the contract was launched, first let's check this verify count variable. Right now is 0. When we pass a valid proof and public input, it's going to count to someone, this variable. Okay, so it is going to ask me for the proof and the public input. So let's pass this. Of course, that you can from we generate the proof by just putting this input in a file, this prover.toml file. But of course, we can pass this on JavaScript, and these inputs can be generated on a front end. Like we're going to use React in a moment. But yeah, of course. And then after this, you generate the proof. This can also be generated in the browser or your mobile, whatever else. And then you be able to get this proof. So we're going to copy this proof and pass it here as parameter. Also, we're going to add some 0x just because Remix expects it in that format. So here you go. Now the public inputs, you can grab them from the verifier.toml file that was also auto-generated for you. So here you can see that it's displayed in this specific format that it's the one that is expected on the verifier side. So yeah, Noir already does that for you, but we're going to put this in an array, and this should be valid. So we confirm, and once this transaction is confirmed, the verifier is, because this is a valid proof, it was confirmed, and the verifier count just summed to 1. So this is like the general process that you want to use when you create any privacy enabled application. You will need to write the circuit and then a smart contract that uses the verifier generated by the circuit and also adds your extra custom logic. But it doesn't stop there. You can have like a more advanced, or you can take a look at this and see like the normal big picture of a CK application that looks exactly like this. Remember, before I only mentioned these two things. You have a front end and you have your contract on the front end. Well, we generated the proof not in a front end but in a console. But you can do that in the front end, generate the proof, and then pass it to the contract. But now we can, what if, for example, if you are creating a mixer app or a privacy voting application? If you yourself create a CK proof on your browser, but then you pass the proof on chain, you lose all your privacy features, right? Because the sender from the other sender from the voting smart contract, it shouldn't be you, right? Because you're going to dox yourself. So you shouldn't pass directly the transactions to a contract if it's a privacy application, if you want to keep the user private. So that's why usually we need a relayer. So the relayer grabs all your transactions. He's not able to impersonify you or to change the things that you did. No, because what you pass to him is a signature, a valid signature, and a proof. Sorry, you pass to him a proof, not a signature, you pass to him a valid proof, so he can't alter the proof. He will need your private keys to alter the proof, so you don't have to give it to him. So it's like a server, like a Web2 server that's running in a backend, in a Web2 backend, that he's relaying the transactions. So he will help you to keep yourself private. And sometimes you will also maybe need a CK proof cloud computation service where from your front end, sometimes generating a proof is very slow and very resource intensive. So maybe imagine that you're building a, if you're doing an application and generating a proof on your phone, it will take too much time. So if privacy is not is not it's not an issue, so you can like ask for a third-party service to generate the proof for you, and you can give your users a better user experience. So both the cloud computing and the relayer are optional, but usually the front end and the contract part are are needed, of course. So let's take a look at this other example that I wanted to bring to you today, which is a chat application, like a private messenger application. So how does it work? So here I already have a comment, and I can write another comment. But this is a smart contract, and this is a smart contract that handles all the comments, but you can comment or post or chat only if you're part of a list. For example, if only NFT holders can can chat here, or only these selected addresses, only addresses that has at least one ETH in their wallets, I don't know, or that have less than one ETH, I don't know, whatever you want to create. So basically, you have a list of addresses, and only them can chat. But when you comment, you can prove that you're part of the list, but you don't reveal which one you are. So this is the privacy part. So, for example, if you're doing a whatever other application, for example, a game like Dark Forest, I don't know, that you can prove that you're a player, but you won't reveal who you are. So yeah, let's try it out. So you will see, and also we're going to go back to the presentation in a moment and see what are the current challenges of creating a CK app, because there are a couple of challenges, and you will see the first challenge right away. So I put the comment here, and if you see, I am not sending this transaction directly on chain. I'm not sending this transaction directly on chain because I want to keep myself private. I don't want to reveal who I am, what is my address. So in the backend, I'm running here a relayer backend, a very simple server that is looking for transactions. And what I'm going to do is, the first step is to sign a transactions to prove that I am part of the list. And I'm going to generate the proof on my browser, not externally, not in a third-party server, not in a CK cloud, on my browser, because here I am here I want to protect my identity. So I have a circuit running in my browser, and he's going to generate a proof that I'm part of that list. But the circuit that and the proof system that I'm running on my browser is going to keep myself private, but it's going to generate a proof that the proof is going to be able, with that proof, I'm going to be able to show that I am part of the list and I want to send this message. And I'm not going to send that proof directly on chain, but what I'm going to do is send that proof that once you generate the proof, you can share it around, because it's all the privacy is already preserved. So I'm going to share the proof with my relayer backend here, and he is going to be the one that is going to send the transaction on chain. So I keep myself private. And as you can see, there is a big problem at this point in time with proving time. So as you can see, it's a very simple application. I'm just generating a proof that I want to post a comment and that I am part of a list. And it's taking a lot of time. And why it takes a lot of time? And the answer for that is that when Ethereum was created, the Ethereum creators didn't know about CK. And they didn't know how great CK is for Ethereum. So the Ethereum creators did coded a lot of stuff that it's not they're not compatible with CK, but they are very resource intensive to connect with CK. So now creating a CK application that uses Ethereum features, it's going to be very hard to prove. So yeah, as you can see now, the proof was generated. This is the proof. This was sent to the relayer. Here. It was sent to the relayer. This is my relayer. So he sent this transaction. This was sent on scroll. And actually, we can take a look at this. This was the transaction. An important part is that this transaction was sent from the relayer, not from the sender of the message. So he will be anonymized. So I can refresh here, and here is my comment. Okay, so this is, as you can see, the usual flow for your privacy protecting application. You will have front end. From the front end, you will have like inputs, and from the inputs to the circuit, we can take a look at the circuit. The inputs to the circuit, what are they? One is your signature, and the other one is your message. So, well, these are the two important ones. The other parameters are because instead of using a list, we're using a Merkle tree because it's cheaper. But yeah, these are the two important parameters: the signature and the message. Okay, so the message is what's input here, and your signature is generated from MetaMask. And if you wonder exactly which features are the most like CK incompatible or CK hard to prove or CK slow to prove, as we mentioned here, it's everything that's regarding to your Ethereum account, because Ethereum accounts use Ketchak for creating your address. So Ethereum uses Ketchak in a lot of places. Whatever place, Ketchak is a hashing method that is not CK friendly. And so, yeah, because we're using this, it's very long to prove. If we use another hashing method, it will be super easier. For example, there is Pedersen hashing, there is Poseidon hashing. Actually, some of these have been very like famous lately because they're very CK friendly. But unfortunately, Ethereum doesn't have this, so doesn't use this by default. And yeah, now it's too late to change them. So now we have to adapt. The good news is that there is a lot of research and a lot of new papers that are coming that will help to make this faster to prove. There are new techniques that are used to prove. But yeah, this is our current state of things. So yeah, just to finish, also like if you have any question again, feel free to put it in the chat. We're going to take a look at them in a moment. But I just wanted to end with this question that I hear very often is, why aren't there many CK apps developed yet? And I think it's because of three reasons. And yeah, I'm going to discuss them like one by one. So first, of course, is the regulation uncertainty. As you know, there is, for example, one Tornado Cash developer in prison right now, which is like a very, of course, sad story. And there is a lot of uncertainty around this. And keep in mind that, of course, the technology can be used in both ways, in the good and bad ways, but the new step that we are, so the CK technology is so big that it also can be used to like prevent and be more compliant. So because the technology is so wide, you can do a lot of things. For example, in the tornado cache example, you can make proof of inclusions. The thing that we did is proof of inclusion. For example, you can prove that you are part of the group and you can chat. This is the chat application that we just mentioned in a moment. But at the same time, you can prove that you deposit some ETH to a mixer, for example, Tornado Cash. The same way that you can prove that you deposit, you can make a proof of inclusion, you can make a proof of exclusion. So in simple terms, you can prove that you deposit some ETH to a mixer, and you can prove also that you are not North Korea, for example. So the CK technology is very wide and you can do a lot of things. And I think we're in very early yet, and it's good to explore all this, all this, all this. It's good to explore all what we're capable of doing today, but the technology is advancing at a super fast pace, and I'm very sure that once the regulators know how to interact with technology, we as a developer will be able to build very compliant software that doesn't sacrifice the user's privacy, but also is able to comply. Okay, but of course, is something that to take into consideration today. Okay, second limitation I see today, as you noticed, long proving time, especially if you're doing stuff with Ketchup or with Ethereum stuff. Usually, if you make an application that doesn't use Ketchup, it's going to be way faster to prove that it was for us in the browser. But of course, if you're doing like an application that we want to offer a good user experience to your users, and we'll have to wait for all these papers to be implemented, so the proving time gets lower. Also, there is the verification cost that may be a bit higher. Or, for example, Scroll has there is a lot of updates coming for Scroll that will decrease the cost in layer 2, and also the finality time, because Scroll, every transaction on Scroll, it's just very similar to what we did today, that all the transactions go to a circuit, a proof is generated, and that proof is passed to Ethereum layer 1 to be secure, so your data and your assets are secure by Ethereum. So you don't have to trust Scroll, you just have to trust Ethereum. So right now, there are many updates that are coming to Scroll that will make the proof shorter and cheaper to prove. So all the transaction on layer 2 will be cheaper, and also the transaction, the finality time is going to be decreasing, because right now the biggest bottleneck for Scroll is the proving time. So if the proving time goes down, you will be able to have your transaction finalized faster on it. Remember that when you transact on Scroll, for example, you make a transaction, it gets confirmed on your MetaMask fast, and you can see your balance change. If you make a swap on Uniswap, it's super fast. If you deposit on Aave or Safe, it's going to be super fast. But if you want to have full certainty that your transaction is secured by Ethereum, it's going to take a couple of minutes. So yeah, hopefully in the no so distant future, we'll have proving time much lower. And the third reason that why CK applications haven't been widely adopted so far, this is more of a technical one, and this is because of the lack of nullifier signature adoption by wallets such as MetaMask or Ravi or whatever. And what does this mean? So when you have CK application, you have usually this primitive, which we didn't discuss today, which are the nullifiers. So what are nullifiers? So nullifiers, you can think about nullifiers as a technique that prevents double spend. So if you generate a proof and you pass it to a contract, you don't, if you generate again the same proof, you shouldn't be able to pass it twice. For example, if you are making a voting application, you want users to vote only one time. So what do? So generate a proof, you pass it to the contract, and then you nullify the proof. So that way, that user can't vote again. The problem is that right now, all the signatures that are available on all the wallets are not nullifiable. This means that you can't do this technique that would prevent user from using your signature again and again. So you have either two options. One is not use like not use an Ethereum account, so you can download nodes. For example, in Tornado Cash, you will download nodes, but you have to store them, and it doesn't give you a good user experience because you have these files that if you want to, for example, if you're doing a voting application, you will have to have these files, and then you will have to pass these files to the contract. But if you lose your file, you're going to lose your vote, so you don't want that. And in the case of and the other possibility is that the wallets implement this a new signing method, but still we still have to wait for them to just verify and for a new EIP to come by and gain a lot of tractions and also do a lot of reviews, because this is a big security. It's important to keep the user safe. So it may take a while to get implemented in your wallets, but yes, it's totally possible. It's actually the most advanced signature function right now is called Plume, Plume, and there are already pull requests on every wallet. And yeah, we're just waiting for all the wallets to accept this project. This is a limitation today, but what does this mean for us as developers? I'm just painting the whole picture here, just for you developers know exactly where in your CK developer journey you may get stuck. So I think at the same time, this is a good opportunity for us devs to get in early, because as you can see, we are extremely early. We're extremely early, and this can give us developers a new super powerful primitive, which is making privacy-enabled applications. This is like a super new and revolutionary feature, and we can start like building today, even with all of these all of these like setbacks. We can start building today. And yeah, so I will like invite all developers, if you are interested in this, just keep learning. Here in the gist, at the end of the gist, I share with you some of my favorite resources to keep learning. And yeah, because I think this is the perfect time to learn about this and to be like just one step ahead, learning the new things. Of course, it's not easy because there is not a lot of documentation, there is not a lot of tools. So yeah, even that will be super helpful for all developers to start contributing, not only with project but also with tooling, because we need a lot of education, we need a lot of tooling, we need a lot of projects that deal with zero knowledge. So yeah, that's my presentation for today, and I don't know if there are any questions.
Thank you so much, Ahmed. So if you mind, between you and me, we have a private chat. There's like a little private chat tab. If you want, feel free to paste the links you were showing, and I can share it with everyone watching here in the chat. But looking at the chat, so there is one question. that we have here, which is, could there be a ZK dApp functioning like a walkie-talkie?
Yeah, I think there can be like a messenger, like one-to-one, like messaging system. Yeah. Also, there is this project Waku that I think they're doing some really cool stuff. Also, private messaging. So yeah, I think that sounds like actually like a good. Sounds also like a good. Um, I share with you the links, but in a very bad format. Sounds like a very something like sounds very similar to understand. But in general, like any privacy enabled feature, like can be done with ZK. And for example, the walkie-talkie example I think is very cool because the message is public, but the sender is private, so you don't know who that is. So yeah, actually, yeah, that sounds like a very fun idea.
Cool. Is there any other questions? Feel free to drop it in the chat. I'll give it 1 minute while we'll still have Ahmed with us. So I just share all the links in the chat, so you should be able to access them. But if you have any questions, reach out to us on our Hackathon Discord channel. We can pass it on to the Scroll team. There's actually a channel specific for Scroll, so feel free to put your questions in there, and we can pass it along. But Ahmed, thanks again so much for taking the time and for joining us, sharing all the knowledge. Remember that Scroll has $10,000 in prices. Feel free to check our dev post page. And yeah, if there's no more questions, then I think we can wrap it up. I hope you all have a great weekend. Keep hacking, and we'll see you in the next Block Magic Hackathon. Thanks, everyone. Bye.
Thank you, everyone. Thanks, Sophia. See you again.
Bye, Ahmed.